Okay, well, thank you everybody for joining me on a Friday evening. Um, David asked me to provide this for SVP several weeks ago, and it was a bit of a different topic. I know that my title is Travels with Dead Horses, but what he had asked was for me to give a bit of a background on my life as a paleontologist. So if you came here expecting to hear more about Ice Age horses or fossil horses, I think I'm about to disappoint you, and so I will apologize for that in advance. But with that in mind, I'm going to stop the video and share my screen. Give me just a moment here. There's that, and now I will stop that share again. Okay, so hopefully everybody can see that. I'm going to go ahead and go through this and then hopefully be able to see any chats that come in. So please bear with me. If I see a chat, I might get a little bit distracted. That's just the way it goes. But with that in mind, let's take some travels with dead horses. But again, this isn't about horses. This is about my search for a life as a vertebrate paleontologist, specifically vertebrate paleontology. I apologize, but I was never terribly interested in invertebrates. And I was interested in animals like these. That is a horse tooth, as I found it sitting at the surface down in Sonora, Mexico, which is, number one, a great place to look for fossils, and number two, a great way to find fossils sitting at the surface. Most of my fossils are found this way, just sitting at the surface. If they were more subtle, I would probably miss them. And I have been working as a paleontologist off and on since 1978, and as a paid paleontologist since 1984. And I am still gobsmacked that I'm able to say that, because it's what I always wanted to do, largely because of this picture. And not just the book that this came from was the How and Why Wonder Book of Dinosaurs, which my parents gave me when I was about 5 or 6 years old. And it excited me about dinosaurs. If I recall correctly, there's nowhere in this book that it uses the word paleontology or paleontologist. So I had no idea what I wanted to do, except I wanted to study dinosaurs. But this was the picture that kicked it over the top. I really, really, really wanted to study Triceratops. That was going to be my future. This was helped by a book that I found at my elementary school library called The Enormous Egg, which involves a dinosaur hatching out of a chicken egg, and the dinosaur is another Triceratops. So there you are. Triceratops is going to be my future. Sadly, I grew up in Southern California, which during the Cretaceous looked a lot like this. It was, most of our rocks here are marine rocks. It is true that in some of those marine rocks, we do have terrestrial dinosaur remains that have washed out to sea and been buried in a marine context, but certainly not enough to build a career on. And to my knowledge, none of those fossils are actually Triceratops fossils. So really nowhere to maneuver there. We did, fortunately for me, have the Natural History Museum of Los Angeles County within driving distance. And so my parents would take me there with the family relatively frequently, and that's where I could get my dinosaur fix, where you could go into the lobby, you could see dinosaurs like this. And while I don't have a picture of it, they did have an Apatosaurus touch bone. And apparently, whenever I got lost in the museum, according to my parents, they knew where to find me. I would be over by the Apatosaurus, just touching it and touching it and touching it. So I was pretty sold on dinosaurs. That's what I wanted to do. Now, my elementary school, my tiny little home library, had more than one book. It had this book on dinosaurs. It also had this book on prehistoric mammals, which didn't appeal to me nearly as much. But I did look through it, and it did mention that there was this site near where we lived called the La Brea Tar Pits, also known as the Death Trap of the Ages. These are Ice Age animals like mammoths, like saber-toothed cats. And so here was a case where there were fossils located relatively near to where I lived. And I was not terribly interested at all. At the time, there was a Rancho La Brea Hall in the Natural History Museum, and I hardly ever visited it. Yes, it was fossils. Yes, they were cool, but they weren't dinosaurs. And so I wasn't terribly interested. And so as a consequence, I gravitated towards the dinosaurs, and that was what I was going to do, kind of amorphously in my future someday. Wouldn't it be cool? All of that changed in the mid-1970s when a millionaire named George C. Page donated $5 million, back when that was real money, to build what became the George C. Page Museum of La Brea Discoveries at the La Brea tar pits. And my mother heard about this in 1978 and learned that they actually had a volunteer program there where you could work in the laboratory and they would teach you to prepare fossils, to clean them up, to put broken ones back together. And since she knew I wanted to be a paleontologist, she said, this might be an opportunity. And I wasn't interested. It's Ice Age animals. Who cares about them? They aren't dinosaurs. But then as I thought about it a little more, I thought, well, maybe I can learn things here that I will then be able to use in my eventual career studying dinosaurs and specifically Triceratops. So in the summer of 1978, I went to La Brea and I signed up for their volunteer program and became a volunteer, that's me over there on the right, in their fishbowl laboratory, where I worked for a few years, where I learned to microfossil sort. I learned to clean asphalt off of old bones. I learned to repair old bones. I learned to identify bones, and it was a lot of fun. And I started to develop a real affinity, as you can imagine, for the ice ages. The challenge here was that this was a relatively, at the time, short-lived event. I started in summer of 1978. Within just a few months, I had completed my 96 hours at La Brea, which meant that at that point I was qualified to work in Pit 91, the current excavation. But there were financial issues. This picture, actually, you see that it's from Science Magazine in 1980. This picture accompanies an article from 1980 that talked about, you can see the title, Mass Job Extinctions at the LA County Museum, where they were talking about huge layoffs, where the lab would be shut down, the paleontology staff would be dismissed, and volunteer program would be shut down, and I would no longer be able to work there. And so I and other volunteers were standing out in front of the lab, encouraging people to donate, and there were complaints, and none of it mattered. In early January of 1981, the county canceled funding. The woman you see in the middle there, Shelley Cox, also a paleontologist who went on to be a Morris Skinner Prize award winner with SVP. She was dismissed. Her partner assistant, Janet Helms, was dismissed. And other than a few staff, curatorial staff, the lab was completely shut down. And so my chance to do this work was pretty much ended. I kept going to the tar pits and I started volunteering as a tour guide, as a docent. And that's when I started to learn how to talk to people and how to convey ideas. And I did that for about 6 months. And then suddenly I come in to do my tour and I see that Shelley's car is back in its accustomed place and she is back at work. And the reason she's back at work is because of George C. Page, who got fed up with seeing his lab that he had spent millions of dollars on empty week after week, month after month. So he started paying Shelley out of his own pocket. And he did that for another 6 months until finally the Museum Association picked her up. She then later was picked up by the county. She had a full career there. She retired recently. But it's because of George C. Page that she was brought back, and it's because of George C. Page that I was able to have a career as a paleontologist. If he doesn't do that, I go on to sell paint and do other stuff. I don't get anywhere near where I am today. Now, beginning in 1980, I started going to college at California State University, Northridge. And I knew I wanted to be a paleontologist, but I still had nothing more concrete than that. It was still very amorphous. I didn't focus. I tried taking some biology classes. They didn't have dinosaurs or fossils in them. I took some geology classes, same thing. So I wasn't terribly focused, and it actually hurt my grades. And then in 1981, a couple of things happened. Number one, the book Lucy, The Beginnings of Humankind was released, and this locked me in. Suddenly, it wasn't dinosaurs anymore. It was hominins. I still recommend reading this book, even though it's out of date. It is a fascinating read, and it totally captured my attention. The other thing that happened in 1981, please laugh if you choose, you won't bother me, is that the movie Raiders of the Lost Ark came out. And this decided me that not only is this what I want to do, this is how I wanted to do it. This was my future, and it was time to lock in and get serious. I was going to become a serious paleontologist. And so with that in mind, I started focusing on paleoanthropology courses, which I was taught by Dr. Bruce Gelvin over there on the left, who encouraged me to study fossil hominins. My senior thesis paper for him was on the evolution of the hominin thumb. But over in geology, I also studied with Linda Ritterbusch down there on the right, who was very encouraging, even though, again, my grades weren't all that great because the bulk of her class was on invertebrates, and I'm not interested in invertebrates. But nevertheless, she was very encouraging, and we remain very good friends today. I see that there's a question in the chat. You mean that's not you on the poster? No, that is not me on the poster. Thank you. I wish I looked half that good. And so does my wife. Here we go. Okay. This is me in 1983. This is actually a picture from the LA Times. They came in to do a story on the volunteer program in the lab. And this is me still volunteering in the laboratory. This is the year I won an award for being the outstanding volunteer. I'm not trying to brag, maybe a little, but I want to emphasize that it's 1983. At this point, I have been volunteering for over 5 years. And for some of you, maybe take out the word volunteer and put in the word avocational paleontologist or amateur paleontologist. I was working weekends when I could on fossils, sometimes weekdays on fossils, not for pay, but I was certainly working on fossils, and I was learning a lot. I think the bulk of what I still use today as a paleontologist is what I learned during this period. But what I also started doing, since now I was serious, was starting to pay attention to the other paleontologists that I was working with. And what I noticed is that each of them had their own study animal. Shelley Cox particularly, she studied bears and was a specialist in short-faced bears. Christopher Shaw studied saber-toothed cats. George Jefferson studied bison. Bill Ackerston studied rodents and saber-toothed cats. So each of them had their own specialty. We also had visiting scientists like Greg McDonald, who, for those of you at SVP, just won an honorary membership in SVP. And he would visit the collections frequently, and he studied ground sloths. You also had Sherry Gust, who was a local student and instructor. She also studied ground sloths. So here's my perception, is that all of these people doing research at the tar pits are studying their own animal. And so it occurred to me, what I need is an animal that nobody else is working on, nobody else is studying. And the only one that presented itself was horses. Nobody there at the time showed any real interest in studying the fossil horses from La Brea. And so that's what I started doing. This is the La Brea horse, Equus occidentalis. And you can tell from the skeleton, they have some beautiful material. They also have literally thousands of fossils. It's the second most common megafaunal plant eater after bison, and it's represented by huge numbers of fossils. It's an enormous collection. You've got adults, subadults, juveniles, prenatal individuals, you've got sick individuals, geriatric individuals, males, females, you've got the whole thing. It's a fantastic sample from which to learn, and then take what you learn there and apply it elsewhere. Not only that, but horses, as you probably can guess, were extremely common in Ice Age deposits, not just in California, but all over North America. Pretty much any Ice Age deposit worth its salt is going to have some horses in it, which means that there is an enormous amount of material available to study. And I looked at that and thought, what an exciting opportunity. But what I quickly realized is what an enormous undertaking to try and understand all of these different animals. And then when you couple that with some of the arcane taxonomy that accompanies these things going back to the 1800s, and all there's over 60 names of named species of horse from the Ice Ages. Not all of them can be valid, and I would have to learn all of those. And I was starting with just one. And so I had my work cut out for me, but still nobody else is doing it. It might occur to you that's why nobody else was doing it, but this is what I decided I was going to start doing. I was going to become a horse specialist. And so now I had, forget Triceratops, we're moving on to bigger and better things. Now, also in the early 1980s, this is 1984, and this is when the Olympics came to Los Angeles. And when that happened, the county of Los Angeles decided they didn't want the world famous La Brea tar pits closed for lack of funding when the world is watching. And so they reopened Pit 91 during the summers. And so we had to get ready for that. So I finally had an opportunity to start working in Pit 91, basically cleaning up all the gooey asphalt. That's me working with Mary Romig there, who taught me so much about how to work, how to excavate, how to maintain the pit, and so on. She was just great people and a real mentor for me when I needed one. And so I finally had the opportunity to actually work in a tar pit or an asphalt deposit. This was also something, forgive me, but I really want to touch on this, because with the staff members, the volunteers would take part in other opportunities. This is all of us taking a road trip up California to attend the Western Association of Vertebrate Paleontology meetings in Berkeley, California. And they made a road trip of it, and they introduced us to geology. This is 1984. We drove all the way from LA up there. It was a fantastic experience. It also introduced me very much to this gentleman here. That's David Whistler, who is the curator of paleontology at the LA County Museum. And the reason this becomes critical is because this is Dave's field area, Red Rock Canyon State Park in California, where you have all of these Miocene rocks exposed. And he'd been working there for years, collecting all sorts of fossils. And every Memorial Day weekend, he would take a group of volunteers and other interested parties out to prospect for and collect fossils. And so this is where I learned to work with fossils that weren't in an asphaltic context, learn to excavate them, learn to collect for microfossils, learn to prepare fossils and harden them and jacket them in the field. In fact, this is a picture of my very first plaster jacket. It was a camel metapodial, and I'm ready to help Dave jacket it. And he said, no, you're doing this one. And so with all these people watching, I got to make my very first jacket. It wasn't terribly great, but it started the process rolling. And so here's where I was learning more traditional paleontology techniques, as opposed to just the stuff that you learn at Rancho La Brea. At Rancho La Brea, though, the tar pits were still open. I should mention that Pit 91 remains open every summer and has done so since 1984. And so in 1985, after all these years, I was hired as one of the lead excavators. And then I was brought back in 1987, and I worked there until 1991. So that skull I just showed you, that's what it looked like when we got it out of the ground. And so that was a great experience as well. It was my first paying job as a paleontologist. Also, working at La Brea gives you a number of opportunities that you might not find anywhere. For example, meeting Sir David Attenborough. He filmed a documentary there called Lost Worlds, Vanished Lives back in 1988, and we had to clean up Pit 91 for him. And I bring that up because I bring up the name because it has never been released in the United States. You can't get it on a DVD here. I think you can find it online, but sadly, it's never been released as a DVD here. But so many famous people would come to La Brea, and working there, you got the chance to meet them. And so that was a pretty special opportunity. You'll also get other special opportunities. There was this movie that wanted to do some filming at the tar pits, and Kate Sibley, who was the business person there, required that somebody on the staff review the script before they would be allowed to film. Excuse me for coughing. And so thank you, Stuart. I feel almost as much of it. No, I'm kidding. Stuart consults all the time. This is my one and only. But I made $800, and they offered to put me in the credits. And I said, absolutely, yes. So, and now, Brendan Fraser's Academy Award winner, I knew him when, that's a lie. I never met the guy. But it's an opportunity that comes when you work at a place like the La Brea Tar Pits. And you also have a lot of media. You get your name in the paper a lot. It turns out paleontology is one way to get your name in the newspapers, and it's even easier when you work at a place like the La Brea Tar Pits. So sometimes you get your name in the papers for things that you really would rather not have your name in the papers for. This is a New York Times article about a time that I actually got stuck in pit 6167. I didn't know this was a sidebar in the newspaper, and I didn't find out about it till I went to school, and all of the other students are smiling at me and laughing and pointing, and I had no idea what was up. So that was fairly embarrassing. I don't know of any other paleontologists who have gotten mired in any of the pits, so I'll put that on my resume at some point. There were also opportunities for research. And again, here the other people at La Brea were so encouraging. This is an example. Shelley Cox was working on cleaning old fossils in old wooden boxes labeled Elephant Miscellaneous. And she came up with the two metacarpals that you see they're on the left-hand side of the picture, but they're the two metacarpals on the right. And they jumped out at her as being very small. And since I was studying horses and had measured all of the horse bones that looked like they would give information, she handed them to me. I was able to compare them. And what you can hopefully see by looking at these blue squares here, these black dots are your Rancho La Brea classic horse sample, the Equus occidentalis sample. These blue squares are clearly substantially smaller, and yet they're adult metacarpals. These are not from juveniles or subadults or dwarves. It's a separate species. And in well over 100 years of excavation at La Brea, a second species of horse had never been documented. And so I was able to give a paper at SVP about that. And now if you read about the horses from La Brea, you will see that there are actually two species represented. Those are the three that we assigned to that. There's also some other postcrania there, but I felt very, very pleased with myself and proud, but emphasizing it doesn't happen unless Shelley hands it off to me and the other staff encouraged me to do something with it. So there was a very encouraging, supportive atmosphere that we had there that I still very much appreciate. Stuart, I don't remember where it would have been 91. I honestly don't remember where it was, but it was in 1991. Here's the challenge with being the lead excavator at the tar pits. Pit 91 is open during the summer. That's no longer the case. Now they have excavators year-round. But back then, I worked full-time during the summer, and then it was back to 1 day a week of maintenance, waiting for the next summer season. And so it wasn't enough to subsist on. And so I looked for other opportunities to make money. And that's when I first started getting into paleontological mitigation, which is big in California. It's where you actually have firms that go out on construction sites and in response to state and municipal laws that require the preservation not only of archaeological remains and biological species and so forth, but also of paleontological resources. And so you can't just plow through these things as you can in other areas. You actually have to recover them, preserve them, and make sure, assuming you're doing your job, that they end up in a repository. And so that was what I started doing at this point in time. You can see other museums that are, if you go to the LA County Museum, this is a paleoparadoxid that they have on display. It's very significant. It was found on a mitigation project. This is the mastodon that forms the center of the Age of Mammals Hall. It was found on a mitigation project. So even if you don't know it, mitigation has been having a huge impact on museums that you encounter. I also started going to graduate school at UCLA, and my committee consisted of Gail Kennedy and Tab Rasmussen in anthropology, and Blair Van Valkenburg, who some of you may know, over in biology. And San Diego. Okay. Thank you, Stuart. And so here the focus was, again, I want to study hominins. I want to study human evolution and horses. I'm kind of playing both sides to the middle. But this was my committee, and it was Tab Rasmussen, you may know, has passed a few years ago, and I miss him because he was instrumental in getting us out of basic anthropology stuff and into other things. For example, he would get us out to the Sespe Formation in California, where we would look for tiny little artiodactyls, also primates, and so on. He was very excited about that. But my study was intended to measure sexual dimorphism in colobus monkeys, because at the time, 1980s, there was still discussion about whether Australopithecus afarensis, the species that includes Lucy, was one species that was highly sexually dimorphic or two separate species. And so I wanted to tease out which features of colobus monkey skulls among different species were sexually dimorphic and which ones were species differences. And so we worked the whole thing out. I went back on my own dime. I paid my own way to get back to the American Museum and study their colobus monkeys. And then I took the train down to the Smithsonian, the Natural History Museum, and studied their colobus monkeys, collected a huge amount of data, brought it back. And this is where things get frustrating. And David, I apologize. You said you wanted me to be aspirational, but I also need to be honest, because when I got back after that trip with all of those data, my major advisor, Gail Kennedy, was furious with me. She insisted that I had not cleared the project with her. I had, but she said that I had not, that she had not approved it, that she did not agree with it, and that she no longer supported me. And so I was in a position where I was told, you will be given, once you submit your thesis, assuming you submit your thesis and it's accepted, you will be given a master's, but you won't be allowed to proceed in the PhD program. Specifically, I was told, you aren't PhD material. Maybe you can find a job in a museum somewhere. That didn't sting as much as you might think, because I never wanted to be in academia. I wanted to be in museums. Specifically, I wanted to be a museum curator. But I also expected to do that with a PhD, and suddenly I wasn't going to be, I wasn't going to do that. So as you can imagine, you're in graduate school, and suddenly you've been booted out of graduate school. What do you do? How do you apply to another graduate school and expect them to accept you? And so, thinking about what to do, an opportunity came up out in the Redlands area of California at the San Bernardino County Museum, where Kathleen Springer was the lead of their mitigation program at the time, and she was looking for a paleontology field supervisor. So I applied for the job. It required a master's, which I had. And so at that point, I suddenly had a full-time job as a paleontologist. Not the one I had in mind, but it was at a museum, and it was full-time. And I thought, I'll do this for a couple of years and then see about getting back into graduate school and working on my PhD. Maybe get a few papers out there so people know who I am. I ended up staying there for almost another quarter century. So that's how this started. What was interesting at the time is that when I started there, the museum was doing a lot of mitigation work in an area of Riverside County called Murrieta, where you had early to middle Pleistocene or Ice Age sediments. And we started finding things like short-faced bear remains, first record of that. We started finding things like that bird bone, which is a giant bird. It's the second largest flying bird from North America. It was the largest at the time. And the morphology of that specimen, which was found in excavation for a parking lot at an AM/PM mini market, the morphology of that convinced paleontologist Ken Campbell at the LA County Museum that what used to be Teratornis incredibilis deserved a different name separate from Teratornis, and so we renamed it Aornis incredibilis. All of that's cool, amazing fossils coming out of there. But I was excited because the most common animal coming out of the Murrieta sediments was horses. And since I was specializing in horses, now I had a whole collection to play with and study and think about. So I was very excited to be there. It wasn't just Riverside County, and it wasn't just horses. We also got to work in the Mojave Desert. For example, this is a mammoth excavation, specifically an animal that we called the Victorville mammoth, so you can imagine where it was found. This is in Victorville. This is us lifting the skull out of the ground to load it into a truck. Partial mammoth skeleton, pretty cool stuff. I also tried to keep my hand in at Red Rock Canyon, which is also in the Mojave Desert. And it was here that I made the single greatest discovery of my entire life. Absolutely, honestly correct. And that's her right there. Her name was Kim Cooper, and we met in 1994 during Memorial Day hunting fossils in the Mojave Desert at Red Rock Canyon. And a friend of ours, Susan Streezer, took this picture of us on our very first day meeting, collecting our very first fossil together. Kim discovered it, and I had collecting gear, so I started helping her collect it. And our career as paleontologists together started at that point. And then Kim was able to come join us working at the museum for a few years after that as a paleontologist as well as a geologist, which was awesome. I enjoyed it then. I still enjoy working with her now, but we'll get to that in a minute. Because about the time that she came on board, we at the museum were involved with an enormous project here. This is currently known as Diamond Valley Lake. It's outside of Hemet, California. And back in the early 90s, this is what it looked like. It was open farmland and onion fields with mountains to the north and south. And the Metropolitan Water Districts of Southern California determined that what they wanted to do is build dams at either end and fill it up with water to become Southern California's largest freshwater reservoir. When they were doing this, it was the largest earth-moving excavation anywhere in North America. And you can see that hopefully from this picture. You're looking across 5 miles, 2 miles wide. Absolutely enormous endeavor with some of the largest construction equipment you can imagine doing the excavating. And as they start digging down to about the 10, 11, 12-foot level, they start hitting fossils. And so again, in California, you were required to preserve those fossils. Nobody had expected this volume of fossils. And so from 1993 through to the end of the early 2000s, 6, sometimes 7 days a week, day shifts, night shifts, we fielded teams of paleontologists to recover this enormous wealth of fossil material, which included some spectacular specimens like this mastodon skull. And I emphasize the mastodon skull because we were finding so many mastodons. Mastodons were very underemphasized in my years at La Brea. They don't find very many there. We don't talk about them a lot. And yet here, it seemed like every other discovery was a mastodon, to the point where the locality got nicknamed the Valley of the Mastodons. And it's still called that today by many people. And we kept finding mastodons. This is a partial mastodon skeleton. And you can see the excavation work going on there. You want to see that movie, Valley of the Mastodons? I think I do too. Let's get rid of that. So here you have a mastodon skeleton, and here we have one of the biggest jackets at the time that I had ever worked on. Granted, whale jackets can be bigger, but this was more than big enough for me. This excavation was actually photographed by local media, and so somebody from the Hemet News caught this picture of me working with Kim. And Kim reminded me today that we had both just come back from our honeymoon to return working on this particular quarry. So the mastodons were a lot of fun, and I have a lot of good memories of digging up that particular one. It took us 3 weeks to get that out of the ground. That said, with all the fossils coming back to the San Bernardino County Museum, yes, the mastodons caught our attention, but when you actually crunch the numbers, it turns out that bison were the most common animals there, at least in terms of the megafauna. There were more bison there than horses, more than mastodons, mammoths, ground sloths, any of that. And that got me thinking. I'd known that bison were the most common herbivore, mega herbivore at the La Brea tar pits. And then when I moved out to the museum and they were working in Murrieta, the most common herbivores were horses. And so I didn't know at the time if that was a difference in age of sediments or if it was a difference in geographic region, where maybe the bison just didn't make it inland as much as the horses did. But by finding all these bison at Diamond Valley Lake in the late Pleistocene, it confirmed that no, what you're seeing is that bison are all over the place in the latest Pleistocene. And it occurred to me, what happens when you have an ecosystem dominated by horses and camels and mammoths throughout most of the Pleistocene, and then just at the very tail end of it, bison show up. And they don't just show up, they become the dominant land mammal, the keystone species for the region in less than maybe 150,000 years. That's an enormous faunal change in a geological instant. And since that ends with the extinction of the megafauna, it got me really thinking about whether bison might have had some sort of effect, at least it got to the point where you could say, well, this period of climate change at the end of the ice ages is going to be different from earlier periods because of the presence of bison. The question was, how long have bison been here? And at this point in time, there were still papers saying that bison had been here for 250,000 years or 500,000 years. And some of the earliest bison remains were in Southern California. So I started setting myself to finding these bison and looking at how strong the evidence was. In the year 1999 at the San Bernardino County Museum, something wonderful happened. I was promoted to curator. I was no longer field supervisor. I was now curator, which was the job I always wanted. And so I was extremely happy, pleased with myself, as you can probably tell from this picture. Other things happening at about that same time, our biology curator, Bob McKernan, was promoted to museum director. And so rather than having a more typical director who's more administrative in nature, we had an actual scientist, an actual biologist who was dedicated to promoting science and encouraging science and educating people about science from his position as director. And this fit in perfectly with what Kathleen Springer, who is now senior curator of geological sciences, this is what she wanted to do as well. It was time to move on from doing mitigation, and it was time to do actual research, to do what museum scientists do. And she was very clear on that focus. And so as we talk about what's coming up, please realize, we're talking about me, but my career was enabled by Kathleen. And this next stage of it was her vision rather than mine. And you see, she's looking at a case full of fossils from a place called Pinto Basin. Where is Pinto Basin, you're asking yourself? Here's where Pinto Basin is. It's in Joshua Tree National Park. It's in the eastern part of the park. And those sediments you see eroding up in the foreground, those are full of fossil remains of Ice Age animals. And those fossils have been known for literally decades. But as is so common in the Mojave and parts of the Sonoran deserts, those early studies were focused on finding evidence of early people living alongside and killing and butchering the megafauna. And so in the Pinto Basin, this is what was being discussed as well. You can see that these bone fragments were interpreted to be deeply scored as by a blow, presumably from humans rather than from, I don't know, camels. But in any event, this was the story. Nobody really looking at the fossils for the fossils themselves. Enter Greg McDonald. Once again, Greg McDonald. He's so, never mind. We've already sung his praises, but I'm going to sing him some more because he's amazing. And it was he, when he worked for the Park Service, who ventured out to the Pinto Basin and he found this camel metapodial. Excuse me, camelid metapodial. And he suggested that the San Bernardino County Museum had a team that could go out there and start prospecting for and collecting fossils. We asked for money to do that, and we were turned down. We let him know, and he said, you don't go to the Park Service and say, we want to find fossils, give us money. You go to the Park Service and say, you have this strategic plan that requires you to inventory the resources within your various parks and monuments, and so we can provide the expertise to help you meet those required goals and inventory the paleontological resources of Joshua Tree National Park. And they gave us money and they gave us permits. And so we went. So we went back to these deposits and we start finding fossils like this beautiful horse phalanx. Quick story. This is a phalanx. We were out surveying and Kathleen had asked me, what are you looking for? What kinds of bones are you looking for? And I said, I don't know. Some foot elements from horses would be nice, something I could measure. And 5 minutes later, she finds this thing. So if you know Kathleen, and you're looking for a specific kind of fossil, just ask her and then point her in the right direction. So there was some nice stuff there. Kathleen is also responsible for this. It may not look like much, but that is a mammoth tooth. And it is the first record of mammoth from Joshua Tree. And this locked us into the Pleistocene. Mammoths are Pleistocene animals. There was some concern about the date, the age of the sediments, and the age of the remains, but here we clearly have a mammoth tooth, so we know we're in the Pleistocene. And then a few years later, in 2008, we start finding remains of bison. So once again, we know we are in the end part of the Ice Ages, the youngest part of the Ice Ages. At about the same time, we start doing work in the upper Las Vegas Wash in North Las Vegas, Nevada. Now, this actually started as a mitigation program for a transmission line. This transmission line, where because it's on federal land, on Bureau of Land Management land, if you're going to be digging, you're required to mitigate impacts to resources like fossils. And so we were retained to go out there and look for the fossils. The upper Las Vegas Wash has been known for decades and decades as a place that produced fossils. And there's been a lot of excavation in the 1930s, the 1950s, the early 1960s. But it's the same thing as Joshua Tree, where it was mainly archaeologists, and they were mainly looking for evidence of people living alongside and butchering the megafauna. And when they didn't find it, they left it. And so from the mid-1960s up until the early 2000s, virtually no work was going on in the upper Las Vegas Wash. They didn't find what they were looking for. And in terms of paleontology, since it wasn't their focus, they only found about a dozen localities. So not terribly rich. Contrast that with our work on a transmission line, a very narrow and limited and restricted area of study where we found 36 new localities. That's 3 times more than had been discovered in all of the preceding decades. And this caught the Bureau of Land Management's attention. They said, okay, what we need to do is actually survey the whole area for paleontology and see what resources we have here. And so the San Bernardino County Museum was retained to go out in 2003, 2004 and survey the upper Las Vegas Wash and look for fossils. And we found them all over the place. Not only did we find newly eroding fossils, we also found evidence of ancient excavations. This is actually a quarry that was excavated back in the 1930s. And for whatever reason, the paleontologist walked away and left everything behind, and we relocated it. We eventually ended up finding 438 fossil localities, which was far more than anybody anticipated. And we've since found more. We're now up over 600 localities known for. So it's an amazingly rich area that nobody was really focused on because they were looking for the evidence of humans alongside the megafauna. And when they didn't find that, they moved on to other things. And so this is where that was in 2003, 2004, and then in 2008 and onwards, we got money to start collecting some of those remains. And so here we are. Here's the various things that we're looking for. Not only that, as you probably gathered, I'm not a geologist, but just letting you know that while all this was going on, Kathleen and scientists from the United States Geological Survey were redoing the geology of the region, remapping the geology of the region, making it much more extensive, much more precise, and much better dated. And so there was a huge amount of science coming out of here. It started as a mitigation project, but it became something much, much, much bigger and more significant for our understanding of paleoclimate and paleontology in the Mojave Desert. I have to mention that my wife at this point had moved on, but she started going to school at Cal State San Bernardino, and this was her field area. This is the Valley of the Gods, currently Bears Ears National Monument in southeastern Utah, and she started working on Carboniferous Permian vertebrates in that area. And she was working with somebody you may know, Stuart Samita, who is the current vice president of the Society of Vertebrate Paleontology. And so I had the opportunity to go out and work in this area as well, which is a lot of fun. It's God's own country. It's just spectacular out there. Kim also got a job with a mitigation company known as Cogstone Resource Management, based in Orange. That's her in the back row, second from the right. And this was a company started by Sherry Gust, who I mentioned earlier, who is one of the people visiting La Brea, studying ground sloths, using measurements to study them. She eventually left academia and started her own company, and then hired Kim a few years after the company opened up. This is also a period of time where, for fun, we would go do more paleontology, and we'd go down to Mexico and start looking for fossils here in El Golfo de Santa Clara. This is again on a volunteer basis, so I guess in this case we're back to being avocational paleontologists. But this is where Christopher Shaw did his master's thesis. And so all those years growing up at La Brea, I'd heard about El Golfo, and finally I had the opportunity to go there thanks to an individual named Fred Croxon at Arizona Western College. And so you have these beautiful sediments and you have these fossils just sitting there at the surface. Again, that's the only way I know how to find them. I would never find them if it was more difficult. I can even find the occasional horse tooth. So, hey, it's just fun to go down there. You've got the hills with the fossils, you've got the beach with the ocean, and you've got the cantina with the margaritas right in the middle. It's heaven finding fossils down there. So it's about the best paleontology you can do. This is also when I was brought on board part-time as a lecturer at Cal State San Bernardino, where I remain today. And so even though I did not have a career in academia, and I'll leave it to you whether you feel like a lecturer, a part-time lecturer is actually academia. Nevertheless, I started teaching in 2005, and I've been teaching ever since. So I'm coming up on 20 years doing that. And it's thoroughly enjoyable. I'm in the biology department working with Stuart Sumida, and it's a blast. And it keeps my foot in the door of teaching, which is something I enjoy very much. I also started doing research at the Natural History Museum, going back there, not as a little kid looking for the apatosaur, but as a researcher looking for fossil horses and finding them. I was trying to do a review of a kind of small horse known as a stilt-legged horse from the Mojave Desert, and there was this sample from a site known as Gypsum Cave just outside of Las Vegas, Nevada. It's a cave deposit, and you have a number of horses. Actually, I think there's about 11 horses preserved in the sample. But the reason these really caught my eye, I want you to look at them. Hello. There we go. Not sure what happened. Please take a close look at that, and you can see that there's furry bits and ligaments and tendons still clinging to them. These horses were preserved in a cave, and they were essentially mummified. So these aren't mineralized or petrified. These are mummified remains, so they look like last week's lunch. But we're able to get DNA out of them, and we're able to get carbon material out of them. So I know that they're around 13,500 years old. And because the DNA is there, these fossils formed part of a study published in 2005 that talked about a molecular perspective on Pleistocene horses in the New World. And you can see that I'm a very, 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 very junior author on this, in part because of me contributing the fossils from Gypsum Cave. But it was my first introduction to paleogenomics and the molecular approach to understanding fossils. Gypsum Cave also had this book published in 1933 that mentioned the skull of a small horse. And I was working with a researcher at La Brea named Christina Lutz, and she and I poured through that collection and couldn't find the skull, and we didn't know where it might be. So we mentioned it to Sam McLeod and Vanessa Rue, the collection staff there at the time. And sometime later, Vanessa Rue found it. The skull had been in the recent collection because the bones look like last week's lunch. And so that's where the skull was found, and here's what it looked like when Vanessa found it. So thank you, Vanessa. But just a gorgeous skull, beautifully preserved, and it had been in the comparative collection, staring down at the lunch table for about 3 decades. And yet it is also about 13,700 years old, wonderfully preserved. And so we gave a little paper on this back in 2014. This would later become a member of a new genus of horse, because the genomics revealed that this organism, even though it looks like last week's lunch, actually separated off from all living horses, zebras, asses, Kiong, all of them. It separated off that lineage more than 5 million years ago. And so it was given, and not in this paper in 2014, in 2017, it got its own name, Harrington hippus. And I'm just now remembering that I was going to put a slide in about that, and I didn't get to it. So I'll hit this point here, and I apologize for my lack of organization. Even though this is a talk on horses, I wanted to get back to the bison because I was still interested in that question about the impact bison might have had. And so I went through every museum collection I could find, looking at all of those early records of bison from the American Southwest. And in every case, there was either no established context or the fossils were misidentified. They were camels, they were horses, they were, in one case, it was a ground sloth. I don't know how you make that mistake, but it happened. And so in every case, you winnow that stuff out, and suddenly you're left with nothing but young bison, just at the very end of the Pleistocene, after about maybe 200,000 years. And so I published with Shelley Cox, I published our work on looking at those fossils of bison from the Mojave Desert. in 2008, and then I followed it up with my own thoughts on the Pleistocene extinction and how bison might have influenced that in 2010. And again, probably I oversold it in the paper, and people are thinking that I would argue that bison might have contributed to the extinction, and it's possible that they did. But a more important point, I think now, is that the terminal Pleistocene event, climate might very well have been a factor because it was a different fauna. Arguing that these animals had survived earlier periods of climate change, therefore they could have survived this one, assumes that there's no change in the fauna. And demonstrating here that there was a very clear and noticeable and powerful change in the fauna, with a completely different organism becoming the dominant organism, not just in the Southwest, but across most of North America. And I bring this up because I just saw a paper last weekend at SVP where somebody was talking about a large mammal and saying, oh, they survived all those earlier extinction or those earlier climate pulses. And I don't want to be mean, but I'll be honest, I hear that, and what I hear is somebody who I don't think has done their homework. That's the way that is, and so I apologize. Anyway, this remains something that I'm extremely proud of. It is currently my most cited paper that I was sole author or lead author on. I think it's been cited 69 times, according to Google Scholar, 69 times, and that's not bad. I'm sure other people would sneer at that, but for me, I'm pretty happy with the way that turned out. Thank you, David. And that brings me to this. This is not the American Southwest. This is a site in East Africa known as Lady Gararu in the Afar. It's part of the Hadar complex. And there's fossils there just sitting at the surface, just the way I like them. But this is the fossil that got everybody's attention from the region. This is a hominin jaw. This was published in 2015 in Science magazine, and it's interpreted to be the earliest member of our own genus, Homo, anywhere on the planet. And it was found here in sediments younger than the sediments that yielded Lucy and Australopithecus afarensis. The current interpretation, again, you can see from the lower jaws there in the lower right how different this is from classic Australopithecus afarensis. So it looks very clearly like this is the earliest known Homo. Yes, there is going to be some discussion about that amongst paleoanthropologists because there never isn't discussion along those lines, but I find the arguments myself pretty compelling. Lady Gararu is the study area of Kay Reed at the Institute of Human Origins, and I know Kay Reed because of the young person over here on the left. That's Lillian Orloff in this picture, later Lillian Spencer, who was a volunteer at the tar pits, worked with me in Pit 91, also a fellow student at UCLA. And when she graduated from UCLA, she went back east to State University of New York at Stony Brook, where she was studying paleoanthropology. That's her there. And then these are some of her fellow students. There's Margaret Lewis over there on the right, who's our current SVP president. But this picture is taken in Tanzania, because even then, all of these people are interested in working in Eastern Africa and studying paleoanthropology. And so this is how Lillian met Kay Reed, and this is how I met Kay Reed. So years and years later, when Kay Reed is working at Lady Gararu and finding hominins, they're finding other fossils as well, including horse fossils. And so Kay is aware that I study horse fossils, and so she asked me to study the horse fossils from Lady Gararu. And so I went, and more than 3 decades after I first conceived the idea of working in Hadar and working in Eastern Africa, I actually had the opportunity to go there and do that, and I'm still working with that team on those fossils today. They're not in the field right now, obviously. One of the advantages of this, one of the perks of working here, is that you get to do things like visit the actual site where Lucy was found. That's the plaque that was erected where Lucy was found. And also you get to meet Lucy sometimes. And so I had the opportunity to meet her in the museum in Addis Ababa. So from any number of directions, absolutely a dream come true to be able to participate in that. And so here's a picture from 2014, 2015. I'm a curator. I'm going to East Africa. I'm studying horses. I'm publishing left and right, and things are going great. And that's when the bottom falls out, because there was a change in the county of San Bernardino where the Board of Supervisors decided they wanted to take things in a different direction. They wanted to not do research. They wanted to go back to mitigation. They wanted to go back to money making, which we were no longer situated to do. And so research was canceled. Our agreements with the Bureau of Land Management and the Park Service were canceled. Various curators left, and it became a very, very ugly place to work. It was just being honest. I don't want to get negative, but it was an extremely dark time. And I didn't know what I was going to do. The curators were running the front desk register 2 or 3 days a week, and I was running the gift shop on weekends, and I was also supervising the convict laborers on weekends who would come in and clean the museum. That's what we were assigned to do. So yes, my title was curator, but I wasn't a curator anymore. It wasn't the job I wanted anymore. And so you face the music there. Do I want to be called a curator and do this other stuff, or do I want to look for other opportunities? And fortunately for me, another opportunity came up in Orange County at a place known as the John D. Cooper Archaeological and Paleontological Center that was looking for an associate curator of paleontology. The Cooper Center had 4 or 5 decades worth of fossils collected for mitigation projects. Now, I have to emphasize that the Cooper Center is now the Cooper Lab. It is still very much a going concern, and their warehouse looks spectacular. It looks nothing like this. They've done such an enormously wonderful job of cleaning everything up and organizing everything. It's amazing what they've accomplished, and they deserve all the kudos. You should access those collections. But back in 2016, this is what it looked like. And even then, though, they had some wonderful, spectacular fossils available, and it was a whole new realm for me to study. So it was intimidating, but I was excited and looking forward to it. They also had a state-of-the-art lab, largely courtesy of the former associate curator of paleontology, Meredith Riven, who had helped assemble this and pretty much decided what they needed and where they needed it and how it would be organized. And so I was looking forward to working with the team there. And the director was Jerry Lips. The associate curator of archaeology was Janine Peterson, both wonderful people. I also had a chance to work with Jim Parham over at Cal State Fullerton. At the time, there was a partnership between Cal State Fullerton and the County of Orange to run the Cooper Center. And so all 3 of these people were people that I was able to work with and look forward to working with, and I had a great time. We also had a number of Cal State Fullerton students who were retained on an NSF grant to process and catalog all of the fossils. Sounds great, right? This fell apart too. Halfway through my tenure there were disagreements between the county and the university. Jerry Lips left and was replaced by a part-time individual who called Janine and I into his office and informed us that not only was research not a part of our job, but we shouldn't be doing research at all because neither one of us had a PhD. And so therefore, his words, we were not qualified to do research. And so suddenly I'm feeling the imposter syndrome is amazing. Very, very, very frustrating situation. And I didn't know where to jump at this point. I'm sorry, I didn't mean to make it awful, but I'm trying to be honest. For anybody watching this who wants a career as a paleontologist, if you're going to do research, get the PhD so that you never have to be subjected to that. Just don't let it happen. Do whatever it takes. Don't do whatever it takes. God, that came out wrong. But within reason, do what it takes to get the PhD, follow through and make it happen, and the research will flow from that. At that point, Sherry Gust, who I've mentioned a couple of times, she comes over and says, you know, I want to publish some papers with our collections, and you can come write papers with me, and I will pay you half again what the Cooper Center is paying you. And music to my ears. So it was only about a year that I worked at the Cooper Center. It has since, that agreement has collapsed, and now it is just Orange County and it is just the Cooper Lab, and they're doing great. I really mean that. So things are much better there now. But I went to work for Cogstone. I went to go work for a mitigation company, and my timing was perfect because this is their field area. Are you excited by this field area? I was not, but this isn't actually the field area. This is the Los Angeles subway. And what Cogstone was doing at the time and is still doing now is finding fossils underground as part of the subway excavation where they're building the various stations. This is a mammoth leg bone that was discovered and jacketed. Traditional paleontology techniques, but 30, 40, 50 feet under the ground. This is a juvenile mammoth skull. Those are tusks. And this was found down there as well. All of this is mitigation for the subway. Some wonderful specimens being produced there. Both of those specimens were over at La Brea Station, where La Brea and Wilshire Boulevard intersect. This is La Cienega, and each of those LC numbers is a different fossil locality, sometimes with multiple field numbers. That's an incredibly rich assemblage of fossils, and this is nowhere near the La Brea tar pits, so these fossils are not preserved in asphalt. These are just fossils preserved in the Los Angeles basin, like this bison skull. This is how we found it in the ground. This is how it eventually got cleaned up. That's Michael Morris, our preparator, who did a beautiful job salvaging that skull. We also found longhorn bison, bison latifrons. So the bison enthusiast in me is still quite thrilled with some of the stuff we're finding. These are ground sloth remains that Greg McDonald has taken a look at and is convinced that there's probably just a single individual there. Here's some of the bones laid out. Other than the tibia up in the uppermost left, all the rest of these appear to be specimens from a single skeleton of a single individual of ground sloth. All of these will eventually make their way into the LA County Museum of Natural History and eventually be available for research. And as I mentioned, the preservation is just exquisite, and yet it has nothing to do with asphalt. This is just standard, typical, I suppose you would say, fossil preservation. Sherry Gust, as I mentioned, studied sloths, and so she was very excited about what we were finding, as well as the other megafauna, and looking forward to working on them, as well as continuing her studies on, in this case, wolves, with Sue Ware, their paleopathologist, Sue Ware, in the foreground, working at the tar pits, working back in the collections, studying things, and getting ready to study all these fossils coming out of the LA subway. And that ended in November 2019, where Sherry unexpectedly passed away from complications with pneumonia. And none of us saw it coming. It blindsided everybody. She was the president and owner of the company. She was a valued colleague. She was a valued researcher. And it caught all of us completely flat-footed. So suddenly in early 2020, in order to make sure the company keeps running, suddenly I'm on the executive board, suddenly I'm a vice president, and we are going to try and make do without Sherry Gust. And here's a picture of one of our first big team meetings to get everybody on the same page. You can see that's Kim standing behind me there, so she's still with the company and so forth. But this is in February 2020, and I'm sure you realize that that means that this happy-go-lucky picture with nobody wearing any kind of masks at all is right before COVID hits, and that throws yet another few monkey wrenches into the way we're doing things. So over the past several years, my life as a paleontologist has increasingly been moving from one job to another job, to a different job, to a different group of responsibilities, to different situations, and it's been very frustrating, and I'm sure I'm not alone in that. I'm still here. I'm still studying fossils, and right now am sufficiently caught up with my responsibilities that I'm trying to get more research done and produce more. So getting back to that research focus that I do enjoy doing so much, but that just the past few years have been very, very difficult to pull off. So that's it. That's my career. I've done a lot of things. I haven't shaken the earth. I don't feel like, I've made any huge intellectual contributions. I haven't revolutionized the science or anything like that. But I feel like I've done a solid day's work, or a solid life's work over that period. I would also say that I was very fortunate to have the opportunity to work on projects like the Diamond Valley Lake Project, which produced the largest assemblage of Ice Age animals from an open and non-asphaltic context anywhere in the southwestern United States. We found well over 100,000 fossils there, and I'm still very proud of the work we did there. We published on that in 2009, 2010, so with Kathleen as the lead scientist and the lead author there. Those fossils can now be seen down in Hemet at a brand new museum called the Western Science Center that opened in 2006 specifically to house the fossils that we found there. So there is now a new museum in California as a consequence of our efforts finding fossils on this project. And you can go to that museum and you can see some of those fossils on display. There's the mastodon skull in the lower left that I showed you earlier with Kathleen, and I encourage you to go there. But I want to hit another point here. It's not just that there is a museum and the fossils available for research. I'll catch up with the chat in a moment. There is also an entire paleontology staff there now that would not be there otherwise. Alton Dooley and his team are doing great work. They're finding new fossils. They're doing all sorts of exciting stuff there. And none of these people, I love them all to pieces, but none of these people would have had that opportunity if the museum didn't exist, and the museum wouldn't exist unless we had done our homework and collected those fossils from Diamond Valley Lake carefully and responsibly and made sure that we got all of the data preserved. Is that applause, David, or is that shut up, you're over your limit? I don't know which. I'm almost done, so I'm going to keep going. This is the wind up. Because I want to emphasize that this wonderful team you see in front of you took some of those fossils and we named a new species. It turns out that some of those mastodons do not appear to be the same species as mastodons elsewhere in North America. So in just a few years ago, 2019, we named a new species, Mammoth pacificus, the Pacific mastodon, and the little red dots you see are the distribution of that form, and that is going to expand soon. Keep your eyes peeled. We're looking for more of that. With respect to Las Vegas, the work we did there, the fossils we found there, they're all going to the Nevada State Museum or the Las Vegas Museum of Natural History. But perhaps more importantly, the significance of the fossils, the number of fossils, their significance, their importance, led to the creation of a national monument. And so here's another echo of something that and again, I'm not trying to say we did this, blah, 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 but at the same time, this monument would not be there if we hadn't have found the fossils and collected them responsibly, thoroughly, carefully, and made sure that they were preserved. And so this is a huge benefit for everybody. That's the official logo. It is a saber-toothed cat, and I'm particularly proud of that because we're the guys who found the saber-toothed cat, originally in 2003, but reported on in 2016. And then we followed that up the next year with reporting on the entire fauna. And as I mentioned, even after the fauna was written up, Kathleen Springer, now with the United States Geological Survey, has gone on to publish a number of detailed papers on the geology of the region with her colleagues, particularly Dr. Jeff Pagati, and some remarkable things coming out with the geology as well as the paleontology. But I remain a bone person, so I'm focusing on the fossils. We also finally took the large horse species from Las Vegas, and we managed to stick a name on it based on this specimen that was discovered in 2012. And we can now determine that the species of large horse from Las Vegas is different from the species of large horse at the La Brea tar pits, at least based on dental morphology. As far as the La Brea horse and other North American horses, I'm still thinking about them. I'm still studying them. I'm still trying to figure out what's going on. The genomics have kind of thrown a few curveballs my way. That's just the way science works. But one thing, hopefully you have learned from this presentation is that I didn't do any of this stuff by myself. This is all working with other people. And that's hopefully what's going to happen with the horses as well, where I'm working with a team of, in most cases, very young people who have all sorts of new approaches, new techniques, and a huge amount of enthusiasm in working with North American fossil horses. And so I can't wait. We were all co-authors on a paper last year, and we're planning to do more work in the years ahead. And I'm also hoping to get back to East Africa and work on some of the horses there. And so this is my career at the moment. Again, nothing earth-shaking, but certainly there have been some contributions made, and I'm hoping there will still be more. I don't think I'm done yet, but that's where things stand. And I again want to emphasize that this is nothing terribly special about me. What has really led this is the people who have encouraged me and supported me and carried me along and helped me out whenever and wherever I needed it, particularly the young lady in the center. But all of these people were instrumental in me becoming the paleontologist that I am today. And so with that, I'm sorry if I went a little over my time, but thank you very much for your patience. And if there is still time for questions, I am more than happy to try and answer those questions. So thanks very much. I'm going to stop sharing and put my video back on. I'm going to look at that. Okay, stop share and video.
So I want to jump in.
Okay.
Eric being very humble here, but I'm gonna counter that a little bit with the nothing world shaking. And I mean, one of the reasons why I invited Eric to do this talk for this event, I don't know, Eric, if you appreciate how many of those last slides that you showed that you're going to be on someday.
That would be wonderful.
I know that in my time doing paleontology, especially on the West Coast, Eric's been one of the most supportive people that I know of, especially of students that are, students are going into any range of careers within paleo, from ones that are like academic world beaters to ones like me who are just trying to find a way to carve something out and help out a little bit. So.
Well, thank you. I'm
Don't sell yourself short.
No, I'm going to throw back at you though. What you're doing, it has the potential to be integral to paleontological meetings in the future. As things get increasingly expensive, we're going to need people who are able to communicate in this fashion. And you're providing a whole new way of doing it that I think is going to be extremely useful for especially early career researchers, students, and so on to network with people. The key is going to be getting senior people like me participating and being aware that that participation is critical. I don't want to. I'm older, but I don't feel that old. But this technology is not that difficult. But you have to make yourself available for it to work, and you have to realize that there's students out there who are hungry to reach out to senior people and talk with them and form relationships that maybe, if they're in different countries, if they're from disadvantaged economies, maybe they aren't in a position to deal with that. So I'm still looking forward to this weekend and what you've been doing with the virtual museum and with the virtual meeting.
And I've said many times in the past, I don't know if I've said it to your face before, Eric, that every academic society needs an Eric Scott.
Yeah,
my strong, firmly held belief in the power of pursuing a positive impact in whatever form or pathway that may be presented. But anyway, we need to keep trading compliments.
Okay. Thank you.
But yeah, let's see if folks are still. We still got plenty of folks here. If folks have questions for you.
Ooh, I see that one coming. Yes, we do. You don't get much of a signal there, and this is to Patrick. In that part of Los Angeles, the sediments are full of methane. And so you're not allowed to take any electronics with you unless they've been worked out to not have the potential to cause. You have to have a meter with you to measure the amount of methane. And if the alarm goes off, you have to have training in order to, how quickly to take your mask out, put it on, where to go to exit, and so on. So, for example, I can't even wear a watch with a battery down there. I can't take my cell phone down there. So in terms of GPS data, in terms of photography, I'm old. And I remember this stuff we used to use called film. And some of those pictures I showed you from Diamond Valley Lake, the amount of photoshopping I had to do because we shot the pictures, we sent the film off, the film came back, and it was overexposed. It was all just, so you have to fix them up with Photoshop, and now we have that opportunity. So with photography, unless you have a specialized camera, you can't take pictures. And so we're so used to now with our phones and digital cameras, just click, 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 click. I'll take 2 gigabytes of pictures of this horse tooth, and we can't do that down there. So there's a number of challenges that come with working below ground. But we have a very experienced and capable team who are used to doing that. Some of them have been doing it down there for years and are just great people. But yes, that can be a real issue. And Rebecca, thank you so much. And Akiko, thank you so much. That was it. You guys are too easy. Let's talk about horse taxonomy. No.
I'm really glad that you actually told a story about getting stuck because I've heard that story and I didn't want to ask. So you, but to be fair, wasn't it just your boot?
No, it was both of my feet, and and I was actively going down. I was it was spring, but early spring, and okay. There was a pit, one of the open excavations, and somebody had lobbed a big orange traffic cone over the fence into it, and it's just sitting there. This is when David Attenborough was going to be coming by, and he wanted to film there. And so, okay, Eric, you're in charge of the pit. Go get that traffic cone out of there. And so the asphalt at the surface was relatively solid because it's relatively cool. And I yank on the traffic cone and it doesn't budge an inch, but my feet break through the surface and go down. And then I start sinking. I managed to get the traffic cone out. I was with a volunteer, a guy named Michael Charters. He ran back to the lab and he got Shelley Cox and some others, and they came out, I think, with a rake, and they leaned in with the rake and they pulled me out. And that's when I started to pull out of the boots. That's where the boots come from. I started to have my feet pulling out of my boots, and so I'm trying to hook my feet into the boots to bring them out, and Shelley's just livid. She's just, leave the goddamn boots. And you know, we got the boots, but yeah. I think it was in the article. What happened though, when Michael was going back to the lab and I'm still standing there very slowly sinking, and an old man came up with either his kid or his grandkid, and they're like reading the label copy and they're looking, nothing, you know. And so I just sit there sinking, and finally the old guy looks at me and says, are you stuck? And I said, yeah, I'm stuck. And he still nothing. He turns to the kid and he says, that's how the dumb animals got stuck. And then the two of them walked away. That was like, welcome to Los Angeles. That's, yeah. Fortunately, Shelley got there shortly after that. Ooh, a male mammoth in 2021 through isotopic analysis. I would love to do that. The thing is with the fossils, at least at La Brea, is that like all of the stuff you see are pretty much composite skeletons. So what you're looking at is not, you know, you can have, like if you look at that mount that I showed you, that is a skull from one individual and the lower jaws from a completely different individual. So you could maybe take the isotopes from a single skull or a single jaw and do that sort of thing. They've got the material there. But you'd have to be careful to make sure that if you're using uppers and lowers, that you note that they're probably different individuals. Otherwise, you might get a conflicting signal. But that sounds like a wonderful idea for a study for horses or bison. That would be a lot of fun. That would be cool. Thanks, Gene. Absolutely, my pleasure. I obviously went over my time, and again, I apologize for not having the slide on genomics because I wanted to emphasize, and I know we're done, but I also, the challenge with that skull from Gypsum Cave really is that it looks like last week's lunch. I cannot emphasize that enough. It even has wild horse or burro written in pencil on the top. That's how close it is. And yet, I collected the DNA from it, and the DNA says that it separated out from zebras, asses, horses, everything more than 5 million years ago. And that's based off a complete mitochondrial genome and a partial nuclear genome. All right. And so that means that its development, its evolution, its morphology is tracking all other equids, even though it's apparently genetically distinct from them. And to me, that doesn't make a lot of sense. And Rebecca, looking at your question, I think that's a question I would have to look up. They don't go back that far. You start getting into the zebra ancestors and so on. So I would say, I would have to look it up, but I want to say less than 1 million years. True horses don't go back that. No, that's not true. Equiscata would be what's known as a caballine horse, for example, and another phrase for that would be true horses. Whether that species is the same as living horses genetically, we would need to actually find a specimen that has genetic material preserved. That is going to be the challenge with genomics, is that genomics is restricted to organisms that have genetic material preserved, and so many horse fossils out there, including the La Brea horse, don't have that genetic material, so you can't fit them into that construct. And on the other side, horses that do have that genetic material, like the gypsum cave horse, look almost identical to living burros, for example. So it's a very frustrating situation, and it means that there's an underlying biological reality to these animals that isn't being reflected in their anatomy, in their appearance. And as a paleontologist who deals with morphology, who deals with the appearance, that's very intimidating. And yet it's something we have to deal with. Does Equiscata have wolf teeth? Horses have, and just to clarify, there seem to be two schools of thoughts out there about wolf teeth. Some people think they're the canine teeth, which are only present in males. That's not technically what wolf teeth are. If you look at horses, they have 3 premolars and 3 molars, but the first premolar in the jaw is actually the second premolar in the tooth row. The first premolar has been lost evolutionarily, but sometimes there's a small little peg-like teeth in the front of the tooth row that just kind of sticks up above the gum line. That's your wolf tooth. It's the remnant of the first premolar. And yes, some Equiscata do have those. Some Equus occidentalis at the tar pits have those. And the further back you go in time to things like the Hagerman horse, Equus simplicitans, and so forth, the more you see those wolf teeth showing up, and in some cases even being big enough that they're wearing against a tooth on the other side of the jaw. It is very cool. I agree. Horses are cool. But getting back to my talk, I want to emphasize, I did not come into this with horses. I came into this for Triceratops, but I have really learned, I've learned to love horses. They are absolutely amazing animals. I love just about everything about them. I wish we had a bigger yard where we could own one, but we don't, so we can't. Even a miniature horse would probably be too much.
Can I get you a virtual one, Eric? Would you settle for that?
That would make me very happy. Yes.
See what I can do.
Thank you, sir.
There we go. Yeah. Do you want one too, Stuart?
Cartoon horses. It's the best I
got. Do we have any other questions anyone wants to throw into the chat? Maybe one more, just so we can get those of us, especially those on the East Coast, especially, are probably hurting right now.
That's what I was thinking. Is shut up. Let these poor people go to bed.
Right, going once, going twice. All right, I think we're gonna call it there. Eric, thank you again so much for putting together that wonderful presentation and giving us your story. And a couple things for the audience. We've got a lot more stuff tomorrow. I hope you're able to make it. We've got more talks and discussion panels and networking things and all that. If you know of someone that you think would make a good candidate to do a talk like what Eric did this evening, let us know. We want to have more opportunities like this, more talks like this, that we can give folks the opportunity to hear these stories at the virtual meeting next year. So be thinking about it, let us know. We can talk with folks and see how we can integrate more of these kinds of stories into the virtual meeting next year.
Thank you, everybody, for staying up so late. I appreciate it.
I'll take some of the heat for that for scheduling you so late. But yeah,
No,
thank you.
it's absolutely fine.
Thank you, Eric.
Absolutely fine. And it's time for a margarita, I think.
Absolutely. All right. I'll catch you all later. Thanks again.
Take care, everybody. Bye-bye.